Good evening. Let's start the class for today. Let me share the screen. Today we will be focusing on organic chemistry, inorganic chemistry, and chemical calculations. That is there. It's there. Okay. So my chat window is open. You can ask any question, and you can share me your answers as well via WhatsApp. I have my phone also with me. The right conversions that I have given. You can try these eight, all of them at once. Okay, so I will give you around 15 minutes, 15 to 20 minutes. Try this. I'm going to start the discussion at 10:20. Right, start now. Eight conversions. So I will give you some time. Start these conversions. Meanwhile, if you have done, just send me your answers. Yeah. So there are, you can see some conversions that that has been given in the screen. Go through the recordings. Sorry, go through these eight conversions. Sorry, eight conversions and do them. Next, I will be doing uh, chemical calculation questions after this one. Okay, so do this. I'll give you some time until 10:20. Do your best. Then I'm starting at 10:20. After that, chemical calculations keep here. Well, चलो organic कर ले. Once you're done, you can show me the answers via WhatsApp. You have my WhatsApp number, and or you can ask any questions via chat, or you can unmute and ask any questions as well. Number of steps is not given actually. You can use minimum number of steps to do these conversions. Okay. Do whatever you can. Right, I will start. Right. The first one. When you look at this one, carbon atom compared to the carbon atom position, chlorine is in the para position, right? Now, the added aldehyde group, this one, this group is deactivating the benzene ring. That's, you know, something, right? So if it is deactivating in the next step or any other step, chlorine cannot be added to the para position. So therefore, we need to remove the deactivation first. First, we need to activate the benzene ring, then add chlorine, then convert that into COOH group, because COOH group is also deactivating the benzene ring. Right? So we'll start like this. So we need to convert C-double-bond-OH into an activation group. So, you know, alkyl groups are activating the benzene ring, right? Alkyl groups are activating the benzene ring. So easily you can convert COOH, so the aldehyde group, into CH3, right? That means to an alkyl group like this. This can be done by via Clemmensen. Clemmensen I have introduced you in previous classes as well. So zinc Hg concentrated HCl can be used. So then after that you can add chlorine. Chlorine can be added. I have explained this one previous class as well by using chlorine and FeCl3, and you need to heat. You can use Fe dust as well. Then CH3 will direct this one into para position. So you may argue why you are not mentioning about the ortho position one. The ortho position is also there, right? Actually, if you consider this reaction, CH3, when you add FeCl3Cl2 or Fe dust, and when you heat this one, these are the product that you can see actually. This is one product, and we can see para position one as well. And also there is another one. There can be ClCl1, and there can be CH3Cl, Cl, and Cl. But what has been asked is what we need to use is the para position one. But you need to remember all other others are also can be used or can be produced during this reaction, and those also can be used during the reactions or the conversions, right? So in a conversion, you are free to use whatever you want, right? But it should be a correct one. But if there are many products after that reaction, you can use whatever you want. So that is the basic idea behind the synthesis. Okay. So I'm using the para position one. Let me erase this. Now I have para position Cl. Then I can convert this into CH3 can be converted into COOH group very easily by using H plus MnO4 minus OK MnO4. That means the oxidation of CH3 group. Oxidation of CH3 group will convert into COOH, and there will be no problem for the chlorine. So this is how you do this conversion. It can be done in 3 steps. Now කරලා නැත්නම් මෙතනදී ඉගෙන ගන්න ලොකු දේවල් නෙමෙයි ඕගනික් වල තියෙන්නේ, right? So aldehyde group can be converted into or the benzaldehyde can be converted into the given compound, right, through these conversions. Okay, right. Make කරපුවා ඉන්නවනම් හොඳයි. කරපුවා ඉන්නවා. කරේ නැත්නම් මේ ටික ලියා ගන්න. Right. Okay, then the second one. The second one, CH3 CH2OH convert into, yeah, this one, the given product. We are talking about this one, right? CH3 CH2OH. I need to convert CH3 CH2OH to a second, this one COOH and Cl. This is something tricky actually. Anyone who has done this one? Raise your digital hand, then I can. Okay, good. Very good. This is something very tricky one. Like හරියට මේක උත්තරය ආව නම් නියමයි. හරිද? Now we are starting with 2 carbon atoms, and there is a benzene ring, and in the benzene ring it is attached to is attached to a group which has 1 carbon atom. Pretty interesting. And there is a chlorine group in the meta position compared to COOH group. I'm talking about the end result, right? So Benzene ring is also should be there. When we start with the linear component like CH3, CH2OH and ended up with the benzene ring, it should be through the Friedel craft. Benzene ring C එකක් බන්ධගෙන වැඩේ කරගන්න. එහෙම නැත්නම් converting a linear one into an aromatic group, that is through a Friedel craft. There are two types of Friedel craft acylation, Friedel craft alkylation. So alkylation can be done with this given formula or the given component, given alcohol, because alcohol can be converted into a alkyl halide, and alkyl halide can be used for the Friedel craft acylation, right? So let me convert this one into a alkyl halide, CH3, CH2, Cl. For this one, I can use PCl5O, PCl3O, PCl5O, PCl3, right? Then I'm using the Friedel craft acylation. How I do the Friedel craft acylation is, I will add benzene ring and anhydrous AlCl3 while heating. සාමාන්‍ය benzene වලටනේ CH3 CH2 Cl එකක් දාලා anhydrous AlCl3 දාන්නේ. But anyway, we need to have a mixture of anhydrous AlCl3 and the alkyl halide and the benzene. So we have the alkyl halide first. Then you are adding benzene ring and anhydrous AlCl3. Right? So at the end, we will have this one, CH2, CH3. Now this is an alkyl group, right? CH3, CH2 is an alkyl group. Then there is a pretty interesting reaction in benzene. Whenever you have one CH3 group attached to benzene ring or CH2 CH3 is attached to benzene ring, when it is oxidized by using H plus MnO4 minus ions, it is converting into C double OH group. That is something that you need to remember, right? Benzene ring CH3 oxidation, as we saw in the previous one. I'm talking about this one. That is also converting into C double OH. And if I convert this one into, or if I add H plus MnO4 minus ions to this one, then again this one will be converting into C double OH. This is something that you need to remember. Right? Then I can convert this one into this group because C double OH group is a meta position or the meta director. Then I can direct chlorine atom to the meta position by using C double OH group. For this one, I can add Cl2, FeCl3 together with heating. Right. So this is how you do this conversion by using 4 steps actually. There are 4 steps. අපි ටිකෙන් ටික අමාරු ගණන් හදනවා. Gradually තමයි යන්නේ. Right. Any questions on this one? මොන ප්‍රශ්න තියෙනවද? මේක කරන්න. Any questions? Okay. Then the third one I'm taking. This is something very interesting one. Make it pretty tricky part එකක් තියෙනවා. ලියාගත්ත නැති අය ලියාගන්න මේක. Then I'm moving into the next one. CH3 CH CH3Br. This has to be converted into CH3 CH2 CH2 C double bond O CH3. At the end of the day, a ketone is formed. Anyone who has done this one? you know. Now, if you can check the end product and the starting components, the number of carbon atoms has been increased by two atoms, because it is starting from 3 carbon atoms and it is ended up with 5 carbon atoms. So, which means you have to add 2 carbon atoms, right? You are not given any restrictions. You are free to use any component or any organic compound, right? Whatever you want. And the steps are also not restricted in these conversions. Strict right? Now, what I can do is, I need to add 2 carbon atoms. So 2 carbon atoms can be added through, one is Grignard region, and other one is the terminal alkyne or acidic alkyne, or I can use aldol addition as well. I think aldol addition is not completed in your theory classes yet, but you have done Grignard region and you have done acidic alkynes, right? So since you know these two, you know how to add 2 carbon atoms to a group, right? So what I do is, I will convert this one into terminal alkyne, right? Or acidic alkyne. What acidic alkyne make godak lisi, but obviously I can use Grignard region as well, because there is a Br here, and this is an alkyl halide. So alkyl halide can be easily converted into Grignard region. But I'm choosing terminal alkyne way. So I need to convert this one into a acidic alkyne or terminal alkyne, right? So first I will convert this one into this one, right? Then I will add Br2. Here you have to add alcoholic KOH and heating. Then I will have CH3, CHBr, CH2Br. Then again I am adding alcoholic KOH and I am heating. Then I will have CH3, C triple bond CH. Now I have terminal, right? Now I have terminal hydrogen atom, right? Terminal one. The megata I can add 2 carbon atoms, right? So I can use sodium. I can add this one through sodium, or I can add this one through silver, or any other way. Copper, you can use any way, right? So what I shall do is, I am converting this one into sodium. I'm adding this. I'm adding sodium to this one. CH3C triple bond C is sodium. Then I'm adding alkyl halide to this one, right? Which has 2 carbon atoms, because I need 2 carbon atoms here. Then I'm adding CH3C triple bond C. Here I need this one, CH3, CH2, Cl, then CH2, CH3 will be there, right? Now I'm doing the addition of H2O molecules to this one, right? H2O molecules. So to do this one, I'm adding G2 plus equals dilute H2SO4 and heat this one into 60 degrees Celsius. This one add, this one will add double bond O and hydrogen, which means the end product that we need. තියෙන කණි පැත්ත ගහලා එන්නේ දෙකම එකයි. Right. So this is how you handle these type of questions. Any questions? කරපුවා ඉන්නවද මේක? මේක හිතුණා හරි භාගයක් කරපුවා හරි. ප්‍රශ්න තියෙනවා ප්‍රශ්න අහන්න පුළුවන්. Right. උත්තරයක් කියලා තියෙනවා. Sorry, not දැක්කේ නෑ පුතා. Yes. Very good. හදලා තියෙන හැටි හරි. Good. Very good. මම මේ ෆාස්ට් කියන්නේ මම මේ ටිකක් ඔයාලට වෙලාව එලිපොල දෙන්නේ නැත්නම් මටත් දැන් මේ වෙලාව මැනේජ් කරගන්න ඕන නිසා. There's a question, is it must to write 60 degrees Celsius? No. The question is it a must to write 60 degrees Celsius? It's no. You can add delta sign, just delta sign. But it's good if you can remember 60 degrees Celsius. Because it is given in the resource book as well. But just adding delta sign is okay. But you need to add delta sign. If you are not adding the delta sign, then that's wrong. Right? Because heating should be there. Okay. Right. The next question, next one. Number 4. මේක මම වෙලාවක් දෙන්න හදනවද එහෙම? හතරවෙනි එක කරේ නැත්තම් 4 5 6 හදන්න බලන්න. මට පේන්නේ පොඩි වෙලාවක් දෙන්නනේ. 4 5 6 කොහොමද මම කරගෙන යන්නද වැඩේ නැත්තම් ඔයාලා try එකක් දෙනවද? කොහොමද? Okay, I got it. හරි. හතරවෙනි එක හරි වල තියෙන එක. පස්වෙනි එක හොඳයි. දෙකම හරියට කරලා දෙනවා. එහෙමයි. Very good. Right. හතරවෙනි එක පටන් ගන්න නේ. Fourth one. තුන්වෙනි එක ලියාගන්න බැරුණා මේකම හදාගන්නත් පුළුවන් නේ. හතරවෙනි එක පොඩ්ඩක් විතර වගේ හිතන්න තියෙනවා. CH3 CH2OH. This need to be converted into CH3 CH CH3. මේක එක එක විදිහකට හදන්න පුළුවන් නේ. CH3 CH double bond CH CH3. දැන් මේ මම හදනවා මම හදන විදිහටම කරන්න කියලා එකක් නෑ. You can do your own methods. You can use your own methods as well. Right? So there's another one. එකත් හොඳයි. මේකත් හොඳට කරලා තියෙනවා. very good. දැන් මේ කතාව මම කරන විදිය පොඩ්ඩක් බලා ගන්න. මේක මම ටිකක් වෙනස් විදිහකට වගේ මම කරන්න try එකක් දෙන්නම්. එක එක විදිහවල වලට කරන්න පුළුවන්. මේක restriction එකක් අපිට දීලා නැහැ නේ. right. So first time converting this one into a alkyl halide, right? CH3 CH2 Cl. මේකට මම මේ regions දාන්නේ නැහැ. ඔයාලා දාගන්න. උරුදු වෙන්නත් එක්ක කරමු. Then I'm converting this one into a alkene. Okay. CH2 double bond CH2. very වෙලාවත් region එකක් මතක නැත්නම් විතරදී මේක දාගන්න. CH2 double bond CH2. Then after that I am adding Br2 to this one. My aim is to create, because I need to increase the number of carbon atoms here by 2. Deaking වැඩි කරන්න ඕන, right? I need to increase the number of carbon atoms by 2. Okay. Then there are එක පුතෙක් කියලා තිබුණා ඒක he has used green art. That's perfectly okay, right? මම මේක වෙනත් විදිහකට හදලා පෙන්නන්න. ඔයාලා try කරන්න green art වලින්. මම හදන එක ඔයාලා වෙන විදිහකට හදුවට කිසි ප්‍රශ්නයක් නැහැ. That's okay. That's totally okay, right? So I'm converting this one into something like this because I need alkyl acidic alkyne. Then I'm converting this into acidic alkyne. Regions ටික. Then after that I'm doing sodium thing, right? So if you check the first one and the second one, I have increased the number of carbon atoms by 2. Now I have created alkyl halide here. So I can use this alkyl halide to sodium, but the addition should be only 1 CH3 CH2 Cl. දෙකක් දැම්මොත් මේක ඔක්කොම carbon atoms හයක් වෙනවා. There are 2 acidic hydrogen atoms as well. දෙපැත්තේ acidic H දෙකක් තියෙනවා. Then what I do is I will add only 1 sodium to only 1 acidic hydrogen atom. අනිත් එක ඒ විදිහට තියෙනවා. I am not doing anything to other hydrogen atom because I can do this one because that result is also possible. මේක දැම්මයි කියලා දෙකටම එකපාර එනවා කියලා එහෙම නීතියක් නැහැ. දෙකම සෙට් කරන්නත් පුළුවන්. But addition of 1 sodium is also possible result. So I can use that one in the conversions. So what I shall do is I add only 1 sodium to here. Addition of both sodium atom is also possible result. To this one, I am adding this. Then I will have, I'll make it number. Then I have CH3, CH2, C triple bond, CH. Then I can do H2PT addition with quinol in here. Sorry. So you can use this one. So this is one method. එක පුතේ කියලා තිබුණා මේ conversion එක කරලා green art වලින්, that is also correct. Okay. මම පස්වෙනි ගාන ලියාගෙන fifth question or the fifth conversion. This is something very interesting one. CH3 CH2 OH converts into CH3, CH2, CH3, CH2, CH2OH converts into something CH3, CH2, CH2, CH3. Okay, this is quite interesting one, right? Have you done this one? No. First, I will start from the sixth question. Okay. The sixth question. I will leave it to you. Fifth question. Right? So I will do the sixth question. Right? I will press my okay. I will press my this one. I will do this one. Fifth question. I will leave it to you. Do we use green in seventh? In seventh, we can use Greenad as well. Yes. We can use Greenad there, of course. Why not? We can use Greenad. Okay. Right. So the sixth question, fifth question. Right. I will answer your question, Kutab, when I'm doing the seventh one. Okay. Right. Sixth question. This is first question. Okay. Fifth question is a homework. Fifth one. I will leave it to you. Then the sixth question. Sixth question is we need to convert CH3, CH2, C double OH. This has to be converted into CH3, CH2, CH2, bromine. So this is also has to be done with yes, very good. Yeah. Sixth one. Either way, good. So this one I can make a samahara vita karla nathvedi. Make select karad make the first one the start this is starting from a carboxylic acid. Carboxylic acid has a OH part. That OH part can be replaced with Cl part by using PCl5, same as alcohols, right? So same as alcohols, if you haven't done carboxylic acid, alcoholic part can be converted into the OH part can be converted into Cl by using PCl5, right? So I can convert this one into CH3, CH2, C double bond OCl. I need to add benzene ring. I can add the benzene ring through a Friedel-Crafts acylation, not alkylation. So I will add benzene. And anhydrous AlCl3. Then I am adding this one, C double bond O, CH2, CH3. Then this is a deactivator, right? This is a deactivator. So I need to add the next one or the bromine one into the para position. With this deactivator, I can't do that one, right? So I need to convert this one into a activator, right? So let me convert this one into an alkyl group through Clemmensen, concentrated HCl. Then I can convert this one to CH2, CH2, CH3. Then with one step, you can convert this one into the required product. Br2 can be added with FeBr3 or Fe dust with heating. Right? So this one can be used. This is the sixth one. Okay. Right. Any questions on this one? පුතාගේ උත්තරේ මම හත්වෙනි ගාන හදනකොට දෙන්නන්නේ. Is it the only method කියලා අහලා තියෙනවා. It's not the only method. We can use some other method as well for this one. Any questions on sixth one? No. Okay, I will move into the seventh one. Right. So the seventh one, yeah, alkyne is given. Okay, CH2, CH3, and D. Yes. Make a top hydrogen C triple bond CH. This need to be converted into CH2, CH3, and D. හරිද? මම මේක හදලා පෙන්නන්න. හදලා ඉවරලා මට මේකේ උගන්වන්න දෙයක් තියෙනවා. හරිද? I need to teach you something on this conversion. So definitely I have to go through the Prandtl-Kraft acylation. It's very clear here, right? Acylation or alkylation or whatever, right? So what shall I do is I will convert this one into alkylation, right? So you can use acylation as well, of course. Let me go through this one with alkylation, not alkylation, acylation, right? So make it mamu region done at winna CH3 C double bond OH එකක් මට ගහගන්න පුළුවන් මෙතනින්, right? Then I can convert this one into CH3 C double bond OH. This one an oxidation puta. Oxidation of aldehyde can be done through H plus MnO4 minus ions. It can be converted into carboxylic acid through H plus MnO4 minus ions. The previous step I have shown you the previous step as actually. කලින් conversion එක අද කරා. හරිද? Then this one can be converted into CH3 C double bond OCl. PCl5 can be used for this one. මේක කරලා නැත්තම් வெளிய හිතන්න එපා. OH group can be converted into Cl by using PCl5, right? Then I'm doing Prandtl-Kraft acylation. Then I'm having C double bond O CH3, right? Now after that, I need to add D. D means deuterium, H12, hydrogen isotope maker. Then I need to direct D into the para position. This is a deactivator. But then a deactivator. Then I'm converting this deactivator into an activator. I can do that one through Clemmensen, zinc Hg, concentrated HCl. Then I can convert this into a react activator. Then I am adding bromine for this one, or bromine or chlorine. Anything I can add. CH2, CH3. So then I'm doing green iron for this final step, right? How to add green iron? First one is magnesium dry ether. Then I'm adding as a second step D2O. මට මේ final step එක ගැන පොඩ්ඩක් කියන්න ඕන. හරිද? මේකේ organic මං theory කියලා දුන්න අයට මේක මම කියලා දීලා ඇති. If you take අනිත් class එකත් මේක කරලා ඇති. alkyl aryl halide එකක් ගත්තොත් if you take an aryl halide, if you check the resonance structure, so the structures which is created through the mesomeric effect, right? So it's something like this. We need to use the Kekulé structure now for the mesomeric effects. So chlorine, then a lone pair will be donated to here, and it will be broken to here. Then a triple bond will be converted. Sorry, double bond will be created in between these two, and a negative one will be there. And this one will be broken to here, and this one will be going here. Then after that, double bond Cl, and double bond will be created here, and a lone, sorry, negative charge will be come here. Negative charge will be broken in between these two, and negative charge will come to the para position, sorry, ortho position like this, and a double bond Cl will be there, and negative charge will be here. Double bond is created here, created here. So this one will be converted back into this one via this mechanism. So if you closely check this, okay, if you check closely this one, actually the මෙන්න මේක මෙහෙම අපි ඇන්දට because of these 4 steps, this compound is in one of these 4 structure, right? මේක මෙහෙම විදියට නෙමෙයි තියෙන්නේ. ඔක හැමතිස්සෙම electrons එහෙම යමින් පවතින්නේ. They are moving from here to here, here to here, here to here, like that, right? So if you check these 4 structures, 3 out of 4 is having a double bond in between benzene ring and chlorine. That means 75% of the percentage, 75% of the time, there is a double bond between the benzene ring and the chlorine atom. So which means you can't remove the chlorine atom very easily. You can't remove. But Grignard region is that much powerful to remove chlorine and add another atom, D. Benzene ring එකට direct attach වෙලා තියෙන chlorine එකක් remove කරන්න පුළුවන් one and only way through Grignard, right? So එක විදියක් තියෙනවා ඒක තමයි ඔයාලා ඉගෙන ගන්න, right? But this is the most popular and most frequent used method, because you can't replace chlorine very easily due to the double bond in between benzene ring and the chlorine atom. Why the double bond? Because of the mesomeric effects, right? Electrons are moving here and there. 3 out of 4 positions are having a double bond. එක වෙලාවක විතරයි නැත්තේ. Okay. So if you want to remove chlorine, you have to use green arc, right? So this is the method, the answer for the seventh question. So there is a question. So the answers, some answers received. Ahmed Pulampata, very good. Yes, this is also correct. You have used the alkylation actually. I have used the acylation. That's fine. If you use the acylation, one step is increased, right? Yeah. Well, since I have used the acylation, like number of steps has been increased. You have used the alkylation. And it do the same question, same conversion by using the alkylation, Friedel-Crafts alkylation. Yeah, I have used the acylation. Revela mono again of the main acylation, alkylation. I I have used the acylation here. So Friedel-Crafts acylation, but I have used this acylation here. But you can directly use the alkylation because you can convert this alkyne into a alkyl halide, and an alkyl halide can be used for Friedel-Crafts acylation, right? Okay. So 8th question also I will leave it to you to do at home. This is the 8th question. This is the 8th question. Class right? Do it at home and send it to me. Okay. Right. Can you write down this question? This one. Break I'm going to recite the question, right? I'm going to read out the question. You may write it down. A solid mixture. A solid mixture consists of. A solid mixture consists of KNO3 and NaNO3 only. A solid mixture consists of KNO3 and NaNO3 only. 0.372 grams of this solid mixture. 0.372 grams of this solid mixture was thoroughly heated. Was thoroughly heated. And the mass of the resultant residue. And the mass of the resultant residue was 0.308 grams. Mass of the resultant residue was 0.308 grams. Find the mole fraction of KNO3 in the mixture. Find the mole fraction of KNO3 in the mixture within brackets potassium 39, nitrogen 14, oxygen 16. If you need sodium 23. Sorry. I will give you some around 10 minutes time to do this. Give it a try. Little bit of inorganic is also needed. Inorganic ටික තාම ටිකේ නෑ මේක දැන් S block එකේදී ගන්න. පුළුවන් වෙන්න ඕන. කරන්න බෑ. Right. Let me do this question. If you have already doing this one, just continue. Let me do this one. Since the time is also going up. So we have a solid mixture. Whenever you are given such a question, just try to visualize this. We have KNO3 and NaNO3 mixture. So the mixture is 0.387 grams. Sorry, 372. 0.372 grams. And you are heating this one until a constant mass is achieved, right? And the mass is 0.308 grams, right? Now we have been asked what is the molar, what is the mole fraction of KNO3? Yeah, mole fraction of KNO3 in the mixture. Mole fraction. In order to know the mole fraction, we need to know the moles of each and every component. That means KNO3 and NaNO3, right? And also we need to know the reaction, what is happening when the heating is there. Unless you can't do this one. Okay. So the heating reactions are coming from the inorganic part, actually, S block, right? So the KNO3 is heated to KNO2 plus O2, nitrite and oxygen, right? You know those things. And you can put half here to balance this equation. And NaNO3 is also following the same. NaNO2 plus half O2. Right? Now, if you deduct the two masses, you can see how much has been released, right? The released amount is equivalent to the oxygen. Right? So let me find out that one as well. So oxygen mass will be equal to 0.372 grams because both equations are releasing oxygen, right? So that is something that we can take minus 0.308 grams, right? මේ දෙක අපි අඩු කරතින් එහෙම 372 අඩු කරන්න ඕන 346, right? 0.064 grams. So this is oxygen. And also let me assume the moles of, because I need to find the mole fraction, right? So the moles of KNO3 to be X. So this is to be Y then in NaNO3, right? So the mole fraction would be X divided by X plus Y, right? So according to the stoichiometry, moles of KNO2 is also will be X. This one will be half X, X divided by 2. This one will be Y. This one will be Y divided by 2. X divided by 2 and Y divided by 2 is coming from the mole fractions. Sorry, the stoichiometry, right? Then I can build up the equations for this one. I can build up 3 equations. Actually, 3 equations is not required. 2 unknowns, 2 equations is enough. Then I can sort it for X and Y. Okay. So, you know, moles is equal to mass divided by molecular mass, right? So, I can say X is the number of moles of KNO3. No? So let me write it down. Let X and Y to be moles of KNO3 and NaNO3. Then I can build up the equation for the initial mass, right? In terms of X and Y. then X into molecular mass of KNO3 plus Y into molecular mass of NaNO3. So this is the total mass. That should be equal to 0.372 grams. Right. Let's try to find out molecular mass of KNO3. Potassium is 39. Nitrogen is 14. 16 oxygen 16 into 3, that is 48. This is 12, 30, 12 into 1, 21, 5, 6, and 10. So X into 101 X plus NaNO3 Na23 N14 O3 48. 12, 13, 14, 15. Okay. So 85. Correct me if I'm wrong. 5, 3, 4, 8. Yeah, 85. So this will be 85Y. This is 0.372 grams. This is the first equation. So this is considering initial mass. Then I will consider produced oxygen mass, or you can use the remaining mass as well. That's fine, right? But I will use considering produced oxygen mass. Then I can write down the equation, another equation like this: x divided by 2 into 16 plus y divided by 2 into 16. That is equal to 0.064 grams, right? So I can write this down as x plus y is equal to 0.008. This is the second equation. You have two equations, right? Solve it for x and y, and the mole fraction. So once I'm not going to do this one, right? You need to find x and y, right? It's maths, right? How to do this one? 101. So you have to consider these two as then we can write down two equations like this: 101x plus 85y is equal to 0.372. This is the first equation. X plus y is equal to 0.008. This is second equation. I have considered the oxygen mass actually. Then find this one for x you can find, and y you can find. X and y, I have taken x and y to be moles of KNO3 and NaNO3. We have been asked the mole fraction of KNO3. So therefore, mole fraction is denoted by K. Sorry, X KNO3 is equal to X divided by X plus Y. You know mole fraction, right? So this is how you can find this one. Make a now solve karano. Any questions on this one? I'm not going to write down x and y. You have to find x and y because the parallel equations, right? These are, these kind of things, how to handle this, how to handle with this. Then the answer approximately should be 0.5. If you have done this one correctly, I will give you the answer to cross check with your answers. So this one is around like 0.5. You have to get the final answer. Right? Any questions on this one? chemical calculation question. This one. Now I gonna good kadano. In Friday class as well, I am focusing mainly on chemical calculations and energetics mainly. Those two. Any questions on this one? Right. මට මේ ඔයාලගේ මුතත් මට ඩිරෙක්ට් මැසේජ් එකක් දාන්න Zoom එකේ SRA Malaysia Tenura I have your number SRA and Malaysia can you send me your WhatsApp numbers and then I can add your if you have my number just send me your message send me your WhatsApp number then I can add you guys into my list right then I can share the things with you very easily so ගෙදරදී මේ ගන්න ඕන right okay thank you so 36 right okay so the next class I thought of doing inorganic question as well but I will do it I will take it on Friday right so I will be doing this question on Friday this one this is something this takes more time so I will do this one on Friday right Friday we have the class at 10 p.m so Friday class we'll be focusing on inorganic chemistry sorry inorganic chemistry one question and the most things I'll be doing on chemical calculation and energetics අලුත් ගණන් හදනවා සහ පාස් පේපර්ස් ගණනුත් හදනවා මම අද ඇත්තටම හිතාගෙන හිටියේ 2007 8 9 10 ඔය පාස් පේපර්ස් ටික කරන්න but I thought of doing an equation past papers I will start from next week අලුත් අවුරුද්දේ පළවෙනි සතියේ ඉඳලම past papers ටික කරගෙන යනවා chemical calculations inorganic organic and everything right මේකේ structure එක වෙන්නේ I will be announcing you to try the questions before the class then I will be explaining the questions I will be creating a WhatsApp group or Telegram group so I will be sending you what we are going to do that during that class before the class then you try those questions then I will be explaining and I will be discussing the questions in the class okay so let's start the class from here for today thank you very much take care tomorrow sunlight let's meet on Friday right good night thank you